Okay. Good morning all. Yesterday we discussed about the Kepler's first law. The Kepler's first law stated that every planet revolves around the sun in an which shape orbit? Elliptical orbit with sun at one of its foci. That was the Kepler's first law. And the Kepler's second law, what was the other name of Kepler's first law? The Kepler's first law was also named as law of orbits, because it was stating the shape of the orbit. Now come to the second law, Kepler's second law. Kepler's second law is otherwise called law of areas. So I will write it, Kepler's second law. Otherwise law of areas. In every examination there will be a 1 mark question by giving state the law of areas, or otherwise Kepler's second law. State Kepler's second law. So that will be a very important question for you. Come. Yeah. So Kepler's second law states that what is this one? This one is the elliptical orbit, and this one is the major axis, this one is the minor axis. Where is the sun? Sun is kept at one of its foci, right? This is my sun and this is also a focus. So every planet revolves around the sun in an elliptical orbit. So this is my planet also. Okay. So the second law states that the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. The radius vector drawn from sun to the planet sweeps out. Sweeps means like this, sweeping. Sweeps out equal areas in equal intervals of time. This one is the loss from sun to the planet, and after delta t time or after t time, again I am drawing a radius to the planet. So the position for the planet for the first time, it was T1 position, planet was here. Okay. At T2 position, where is the planet? Here. So what is the time interval? Delta t. Okay. So say, for example, 2 seconds. Okay. For 2 seconds time, this is the area covered by the planet. So this much is the area. Say I am calling it as A1 area. Any problem? First time the planet was here, and at the second time the planet is here. It is revolving around the sun. So it should change. So after changing, after 2 seconds, 1 second, 2 seconds, this much area it is sweeping. Sweeping means brooming. Like that. Same meaning. The radius vector drawn from sun to this planet sweeps out some particular area. What is that area? A1 area. Okay. Now moving to another interval. Now here is my T1. Planet is revolving and it comes here. Okay. And it coming here. So planet came here after some more time. So here is the planet. So at T1 position, planet is here. But here see, the orbit is so closer to the sun. So it has to move little more faster, right? So after 2 seconds, it will come here, delta T2. So which is the time interval? Delta T, this much. How much it is? 2 seconds. Say 2 seconds. And what is the area here? Say it is A2. Okay. So this is the time from T1 to T2 and this is the time interval, same time interval of this one. How much? 2 seconds, 2 seconds. My law is that one, area will be same for both the sides. This area and this area will be same. For same time interval, area covering will be same. This is the law. Understood? The radius vector drawn from sun to the planet sweeps out equal areas in equal interval of time. Say 2 meter square area or 5 meter square area. Here this much, again 5 meter square, again 5 meter square, like that, sweeping out equal areas in equal interval of time. Understood? So say the law once more. The radius vector, this is the radius vector, drawn from sun to the planet sweeps out equal area in both sides in equal interval of time. I can draw here also, no problem. Okay, here is the planet first position, here is the planet second position, same time interval. How much? 2 seconds. It was our time interval, no? So this area will be also equal. 1, 2, 3. These three areas will be same. Understood? Here also I can draw. Suppose I am giving delta t is equal 2 seconds. Will the area be same? Yes. The area will be same. That is, we will call it as the aerial velocity will be same. The aerial velocity will be same. Or in a particular time interval, the area covering will be same for the planet. Understood? This is the law. So what is Kepler's law? Can you state this law once more? Kepler's law of areas. The radius vector that is drawn from the sun to the planet sweeps out, wipe out equal areas in equal interval of time. That is Kepler's law of areas. Otherwise, we can call it as the aerial velocity. Aerial velocity is constant. The aerial velocity is constant. Understood? So this is law of areas. Hope you understood. Yes. So what was the first law? Every planet revolves around the sun in an elliptical orbit, keeping sun at one of its foci. And the second law, radius vector from the sun to the planet sweeps out equal areas in equal interval of time. Third law is all about, one more law is there, that is Kepler's third law. What is this axis called? Axis called major axis. And half distance is called semi-major axis. In mathematics, circle radius is indicating by which letter? R. In mathematics, semi-major axis usually it is representing by A. Okay. And semi-minor axis usually representing by B. Okay. And where is the sun? Here or here. Two focus. First focus, second focus. F1, F2. I am placing sun here. Any problem? No problem. So the next problem is, this one is my planet. So in an orbit, what is actually planet doing? Planet is revolving around the star, sun, right? So the planet is revolving. Earth is revolving. The word is revolution. Rotation means rotating on its axis, but revolution means revolving around the sun, moving around the sun. So the planet is moving like this, right? So there should be a time period. Okay, time period means the time required to complete one revolution. So that time period, the square of the time period is directly proportional to a cube. Can you state this law by this mathematical expression? T square proportional to a cube. I told you what is T? Time period. Time period of revolution. Time required to complete one revolution. So can you state this law? Kepler's law, third law states that. Who can say? Prangana. Kepler's third law states that So I have given you the mathematical expression. This is the mathematical form of Kepler's third law. T square, this sign means proportional to a cube, right? So how you can state this law? The square of the time period of revolution of a planet around the sun is not proportional, directly proportional to no. The cube of the semi-major axis. Easy, no? This is how we will formulate laws from mathematical forms. Understood? So how you can say? Simply study this step, you can write the law. The square of, you can note it down, this particular equation. The square of the, if you know this much, you can simply write the law. No need to by heart. How easy it is. The square of the time period of revolution of the planet around the sun is directly proportional to cube of the semi-major axis. Semi-major axis, instead of A you can use R, no problem. Any letter you can use, R also you can use. Some of the textbooks they are using R, but usually A is representing semi-major axis, B is representing semi-minor axis. R is usual letter for radius. Okay, no need to just write this mathematical form, enough. And T, what is T? T may be a new letter for you. What is T? The time period of revolution. Okay. So the Kepler's first law, the other name was law of orbits. The Kepler's second law, the other name was law of areas. It gave you the idea about area. And the third law, can you suggest me a name? Law of periods, because it is giving you the idea about period, the revolution period. So I will call it as law of periods, law of orbits, law of areas. See that rhyme? Orbits, areas, periods. Wonderful names. So these are the Kepler's three laws. Hope you understood. Yes. Now we will move to Newton's gravitational law. Okay, the main concept. So after all these things, Newton, Galileo, all those scientists found out many mathematical theorems, their own suggestions. Then after that, with proper evidence, proper mathematical steps, they found out the laws. See students, Kepler didn't directly give this law. He has to work for a whole book to prove this equation. This equation I am writing simply directly, but this equation needs a big derivation. That you will study in, if you are opting physics and all, or astrophysics and all, you will study in your future classes. 3-4 pages of derivation it is having to reach at t square proportional to a cube. I cannot say it right directly, right? So these all need proper justification, and he has proved it. That's why a proved theorem only can be stated as a law. Otherwise it's just a theorem only. So now it's a law means he has got justification and he directly proved it. Okay. So now we will move to Newton's universal law of gravitation. So Newton's universal law of gravitation, it was found out by whom? Sir Isaac Newton. He was a great mathematician actually, not physicist. He was a mathematician. Mathematician in the sense, he found out many mathematical ideas such as sets, matrices, then differential equations, integral results. All these things were found out by Sir Isaac Newton. And one of its famous books were the mathematical principles of natural philosophy. This was one of his famous book, the famous book of physics plus mathematics, the mathematical principles of natural philosophy. This was the book of Sir Isaac Newton. In this book, he invented the law, the universal law of gravitation. He wrote the law in this particular book. Understood? So what was that, the law, the name of the law? The universal law of gravitation. So better to, yes. So better to study the name of this book also for more concept. Okay, so you can read that book also. It is available in the internet. Many ideas are there. Many natural philosophy ideas are there. What is the name? The Mathematical Principles of Natural Philosophy. And saying about the universal law of gravitation, it is familiar for you, right? You have studied it in class 9, the basic ideas. What was the law? And in chapter 1 also we have discussed the gravitational force. What is that? Every body in this universe attracts each other. That's all. Every body in this universe attracts each other, not repels each other. Every body in this universe attracts each other. That's all. Everybody. So you all are attracting each other, right? Even you and the other stars are attracting each other. You and your parents are attracting each other. You and a person at America are attracting each other. Right? Everybody in this universe are attracting each other. You and me attracting? Yes? Yes. Pen and book attracting? Yes. Duster and you attracting? Yes. Everything in this universe attracting each other. So, suppose there are two bodies, M1, M2. They are separated with a distance D. Okay, understood? First body M1, second body M2, and they are separated by a distance D. Okay, so according to Newton's law of gravitation, he stated the law like this. I will just give you the mathematical expression. State me the law yourself. F proportional to, can you state me the law? F proportional to M1, M2. Can you state me the law? Can you state me a sentence from this one? F means gravitational force. This letter you know? Yeah, proportionality. This one? Then tell me. The gravitational force is directly proportional to product of two masses, M1 and M2. Okay. Next one. I will give this one as equation number 1. Second one. F proportional to 1 by d square. Can you state this law? This mathematical form. The gravitational force is, whenever 1 by d square is there, means you can call it as inverse proportionality. So otherwise you can call F directly proportional to 1 by d square. Otherwise how I can name it as? The gravitational force is inversely proportional to, no, not d square, tell in sentence. The gravitational force is inversely proportional to square of the distance between the two bodies. Okay, this is my body number 1, this is my body number 2. The gravitational force is inversely proportional to the square of the distance between the two bodies. Understood? This is my equation number 2. This is my LHS, left hand side. This is my RHS. My LHS, both the letters are same, right? Both the quantities are same. Which quantity? Gravitational force. So I can equate. Equating 1 and 2 in LHS, what can I get? F proportional to M1, M2 divided by d square, right? This is Newton's law of gravitation. Understood? When I combining these two equations, I will get F proportional to M1, M2 by d square. Now you can directly state me the law. The Newton's law of gravitation states that the gravitational force or every body in this universe attracts with a force which is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between the two bodies. Every body in this universe attracts each other with a force which is directly proportional to the product of the masses of the two bodies and is inversely proportional to the square of the distance between them. Any worries? No worries. To avoid this proportionality constant, you might have studied in mathematics classes. What I can do? just include a constant, right? Multiply with a constant, you can avoid that proportionality sign. Any constants you can use, and here constant value, it was determined by Sir Cavendish, a famous scientist, and Cavendish gave the value G. The proportionality constant is named as G, and G has a name called universal gravitational constant. Okay, so what the law will come? F equals G m1 m2 divided by d square. Now equation K, you can directly do the numericals. F equals capital G m1 m2 divided by d square. Okay, what is the name for G? G equals universal gravitational constant. Okay, its value was found out by Cavendish, a scientist. Okay, the value is 6.67 into 10 power minus 11 Newton meter square per kilogram square. This is the unit. Newton meter square per kilogram square unit. Cross multiplication, I will give it in a fresh page. Right? So can you find out an equation for G from here? Yes. G equals F d square by m1 m2. That's why I wrote this unit here. F unit is Newton. D square unit, D is nothing but it's a length. It's a length, not a distance. We will call everything in fundamental quantities. Length is the first fundamental quantity. D is nothing but it's a length. Length unit is meter. Square unit meter square. Divided by m1 unit. m1 is nothing but it's a mass. Mass SI unit is kg. Again m2. m2 is nothing but it's a mass. SI unit kg. kg into kg. kg square. Finished. That's why unit came. Understood? Now I have a question for you. Please do it in your notebook. My question is, find, those who are seeing in the online class also, please try to do this one. Find the dimension for G. Find the dimensional value or dimension for G, universal gravitational constant. In second chapter you might have studied there are two types of constants. One is having dimensionless constant and one is having dimension constant. So G is a dimension having constant. So find out the dimension for G. I have given you the equation also here, so it will be easy for you. Those who are having doubt, I will do definitely after 2 minutes. Try to do. I got this question in my entrance examination. I expected that question, so I by-hearted the value and directly bubbled it. Didn't waste time. Okay. So that much importance that question is having. Find the dimension for G. Two questions you can expect in your NEET examination from dimensions. Okay. One question, simple one. Another question, tougher. Okay. This one will be a simple question. One will be a tougher one. Two questions definitely from. And also class 11, listen, from physics class 11 constitute many of the numerical problems out of this higher secondary studies, and you can expect 55 to 60% questions from class 11 physics topics, especially from motion, units and dimension, laws of motion, gravitation, work energy, power. Okay, first 8 chapters. So please be thorough with the equations. How many equations we have studied? 3 or 4 equations we have studied from this chapter itself. G value, F value, T value, then aerial velocity value, all these things. What is the dimension? Let me try to do. Okay, those who didn't do, let me help. See students, G equals F d square by M1, M2, right? This was the equation, and to get dimension I have to put square brackets here, right? Yes, then F d square. This is the usual process, but to save time in entrance examination, no need to do like this, but in theory examination, do like this. This is the proper way. Then what is the dimension for force? Mass into acceleration, it is nothing but ml t raised to minus 2, right? Into d square, nothing but L square, length, divided by m1, nothing but mass, that's the fundamental quantity, m into m. Correct? ml square, what I will get? It will give you m L cube t raised to minus 2 divided by m square, right? Final equation. This 2 will go up and it will turn to m raised to minus 2, right? m into minus 2, a raised to m into a raised to n, a raised to m plus n, m raised to minus 1. L cube t raised to minus 2, right? Hope you all got the answer. Those who didn't get, you can do it once more. Okay students, work out this problem. We stop our classes right here. Tomorrow we will study about acceleration due to gravity and its relation with universal gravitational constant capital G. Thank you students. Bye.